Matrices and matrix operations are something that you probably haven't seen yet. Sometimes we can get to them in math analysis, but basically they're just an array of numbers in a detailed order where the dimensions or the order of it is found by doing rows by columns. So our rows are going to go this way. So this would be row 1, this one would be row 2. If I had another one, it would be row 3, and these can go on until you get to the bottom. And then of course we have columns, so this will be column 1, column 2, column 3, and these of course continue as well. So you have to make sure that you know the dimensions or the order of each matrix that you work with, because certain operations work different ways. So when we're adding or subtracting matrices, they have to have the exact same dimensions, and then we just add these term by term. So this one is a 2 by 2 because I have 2 rows. So row 1, row 2. So rows 2, and then by column 1, column 2. So a 2 by 2. So this one likewise is the same dimension. So this one is a 2 by 2 also. So my answer will be a 2 by 2. So at this point, all we have to do is add up the ones that are in the same locations. So this is 4 plus 1. That's going to give me a 5. Then I have a 7, I have a 7 plus 0, so that's going to give me a 7. Then I'm going to have a 0 plus 3 will give me the 3. And then last but not least, you have negative 2 and 2, so that's going to give you a 0. So this would be your final answer for this question. So there are two different kinds of multiplication that go with matrices. This one is a scalar. So this outside number that I have just labeled as k is your scalar. So what you do is distribute it to each and every term on the inside. Now, it doesn't matter what size these are. It can be any dimension. As you can see in this first example with this, all you're going to do is distribute to find 3f. So if f is given to be the matrix that's there, all I have to do is 3 times each one of those. So 3 times 4 is 12, 3 times 2 is 6, 3 times 1, of course, is 3, 3 and 6 is 18, 3 and negative 3 is negative 9, and 3 times 3 times 5 would be 15. So that would be my answer for this scalar multiplication. Now these can get more complicated because you could have more multiplications and then adding or subtracting along with it. So be sure that you do scalar multiplication before you add or subtract matrices. Matrix multiplication is the other kind, and this one is more complicated because you have to determine your dimensions before you get started, and very specifically, this number has to identically match that number. If those two don't match, it's not possible. If they do match, then this number and this number will tell you how big your answer is. These are the dimensions of the answer. So for this first example, I've made it very simplistic so that you have a 2 by 2 times a 2 by 2. And the way this works is very specific. So if I'm going to do A times B, then what I'm going to do is take this times this. That's my first one. So I have negative 3 times negative 4. And then we're going to add, and I move in two directions. I slide one to the right, and I move down. So now I've got negative 4 times negative 3. I'll do that in blue so you can see the difference. Now, what we do from here is reset this. So I'm going to go and reset so that I can start to multiply over. So when we reset, we start back at this negative 3, and this time we're going to multiply by this 4. And when you do this, you slide to the right. So you're going to have negative 3 times 4. And then you're going to add to that, sliding to the right one and down one, negative 4 times negative 1. And this will be the entire top row. because you use the top row on the left matrix A. Now we reset again. And I'm also going to change this 0 here into the number 1, just so that you can see the differences. So when we reset this time, we're going below because we're changing our row. So we're going to multiply 0 times -4, and it goes below. So 0 times -4. And then we slide to the right one, and we go down 1. So then we're going to add and multiply 1 times -3. And then we reset again. And this time we're going to multiply 0 times 4. And we write that over here. And then we're going to add that to the multiplication of this 1 times this -1. I didn't continue with my blue, so I apologize for that. But this process is basically going across in one and down in the other. And then you go across that same one and slide over as many times as you need to. And that will comprise the whole first row in your answer matrix. And then you will reset all that and go down a row and then do the same thing. So essentially you're making the number 7 because you're going across a row and down a column. So you've got the number 7 right there that you're making. And then you just slide across until you take care of all of it. So then you just do those multiplications and additions until you get to your answer matrix. So this one will be -12, 12 plus 12 is 24. You have -12 plus 4 is -8. You've got 0 plus a -3, and you've got 0 plus a -1. So there would be your answer matrix. This takes some practice, and as the matrices get larger, these become longer versions. So be sure that you're checking to see that the first column and the first row in the second one, the dimensions match. So for this one, we have the multiplication of C times B. So I'm looking at these dimensions. So this one, of course, is a 3 by 3. It's a square matrix. This one, however, has three rows, but only 2 columns. So what I'm looking for here is the fact that this 3 matches this 3, so it is possible. If those two numbers do not match, then it's not possible and you don't have to do anything. And then as I look at what's left, I know that my answer matrix is going to be a 3 by 2. So when I finish, I should have 3 rows and 2 columns. So then we start our multiplications. So we're going to go across this row, and then we're going to go down this column. And you slide 1 as you go. So you've got -3 times -4. And then we're going to add to that 3 times +4. And then add to that -1 times 3. And then we have to go down the next column over here. So we slide 1 to the right and we add in these multiplications. So we're going to have -3 times 5. We're going to have the addition of 3 times -1 and one more addition of the last -1 times the last -5. Now we need 3 rows, so I'm going to extend that just a little bit, and we only need 2 columns. So those are our 2 columns. So now we have to reset this and start all over again. So since we've used that first row, you can even mark it out so you don't get confused. So now we're going to go down 1. We move down to the second row and start back at the first column. So we're going to have 2 times -4 plus 0 times +4 plus -5 times +3. And then we move to the second column. So we're going to have 2 times 5 plus 0 times -1. And lastly, in this one, -5 times -5. And then we're done with that row. So now we move to the bottom and start over. So we have -4 times -4. We have -4 times +4. And we have -2 times +3. And then we move to the last, which is negative 4 times 5. Then we have negative 4 times negative 1. And then we're going to have negative 2 times negative 5. So once all the matrix is created, then you're just going through and you're finding the final answers. You can show as many or as few steps with this as you need. I am not going to walk through all the steps. I'm just going to give you the final answer, which is this matrix. And your homework, sometimes each individual entry is going to be a point. Sometimes it's just a, whatever size matrix. And if you miss one number, it's wrong. Come quiz day, you don't have quizzes. Come test day, if you have maybe 9 that you're filling in and you only miss 1, then you'll get most of your points back. If you miss more than 2, you're not going to get half credit, or you will only get half credit. So be careful with your calculations and see me with questions.